Hello. Um, for the class today, we talked about we practice on problems with greedy algorithms. Okay, so the idea of the greedy algorithm is that you pretty much all the algorithm that we learn in this class, right? When we have problems, then the algorithm has to make decision. Okay. Yeah. He has to make decision either like to pick this or pick that or decide that you would do this and you would do that. Okay. So the idea of the greedy algorithm is like you just look at the data that is currently available to you, right? Data that is currently in front of you or like something is in your focus, right? For example, you have you want to eat something, right? And then you just like, okay, I'm gonna eat something. Then there are many things you can pick, right? But actually, you just like, I'm gonna eat the first one, something like that. So when you make decisions and then and you just look at something like really locally, something like is in front of you and make decision based on that. Okay, if you do that, we typically call this kind of algorithm as greedy. Okay, so you make decisions based on something like really local. Okay, um, something that you can decide pretty easily. Okay, you don't really think like, okay, I'm gonna do this because of that and those. Okay, so this is a rough way to characterize greedy algorithms. Okay, so you make decision based on some simple rule, maybe not that simple, right? Okay, but uh, simple rules. Okay, like without really thinking about much about like the consequences and so on. And many times this kind of rule doesn't really work, but in many cases it works really well. Okay, so the task today that we will try to work on usually has really something like simple rules like that. So it might be helpful to look at them, and if you can sort of like figure out the rules to make decisions, then it'll make your life much easier. Okay, and in class, in the algorithm class, you I think you learn how to prove the correctness of these rules. Okay, we will as we are like a programming class, we might not really need that. We might not we will not ask you to write proofs, but if you can think about in your head roughly why the greedy rules that you devised is working based on the proof technique that you learn from class, it'll be really good. Okay, so let me name the two technique that you use in class. First is the greedy stay ahead, right? You make sure that the greedy comparing to any kind of decision makers, greedy algorithms somehow is ahead in some measures. Like it's always it's not going to be worse than any other kind of decision making. Okay, so this is the first technique. The second one is called exchange argument, which basically say that the decision that you made um, when comparing to the optimal solutions, you can somehow transform the optimal solution to the solution that you actually produce by the algorithms. The way you do that is by smallly change some smaller parts of the optimal solution iteratively until you get to the solution that the algorithm is reporting. Okay, so that's the exchange document. When we look at the task, I'm gonna review the two techniques again. Okay, so these are the proof techniques that you can think about. Okay, all right. So let's look at the problem set. Okay, so these are the problem set at the top. Okay, probably up to this. Okay, like this one. Okay, the top ones. There are some optional tasks. There might be more optional tasks when on Monday, but Some of them are optional. Okay. So let's look at the first one. So this is the one that you learn in the algorithm class, interval scheduling. Okay. So let's see what it is. You should go ahead and read it. I'm gonna maybe you pause the video and then I'll give you a review and a small discussion on how to find the solutions. Okay, so I hope you has read the task statement. Okay, so the idea is that you have n tasks, n requests. Okay, for each request you have the starting time and the ending time. Okay, you can view this each request as an interval. That's why we call interval scheduling. You have this and that, and some of that, like that. Okay, so this is the time. Okay, so this is same S1, T1, something like that. We have many tasks. Okay, you would like to pick a set of tasks, a set of requests that that are compatible. You can think of this as you have a one room, and these are like the time that each group would like to book the room, and you would like to give the rooms to as many people as possible. Okay, so the idea is that if you give if you accept to requests like this, then they'll fight over this range of time, right? But you can do this. You can even have you can give both. You can accept both of these requests. You can even do the request like this. If you have the starting time exactly at the end time of the previous request, that would be okay as well. Okay, but you cannot have intersection larger than a single point. Okay, so if you recall from the lecture, the idea is to work on this is that you would follow this rule. So basically, you picked the one with the earliest finishing time. Okay, so earliest finish first. So if you like to say it shortly, okay. So in this case, you would pick you find the one. Okay, this is a finishing time. So you find this one, and then you say you pick this, and then you remove everyone that is in conflict with this guy, and then you pick another one that finished first this, and then you remove everything that is in conflict with this guy. Okay, and then you pick one which finished first, like this one, and then you remove the one with in conflict with it, and then again and again, something like that. Okay, maybe this one, and you remove. Okay, so that's the idea. Typically, when you implement this kind of algorithms, you need to sort something. Okay, you in greediest algorithm you sort all the time. Okay, so don't write the sorting algorithm yourself. You can use the library STL libraries, and if you need to sort based on many factors, you need to sort something based on the finishing time, and you would like to have to know the numbers, the index of the task, you can use pair. Okay, you can use pair. Okay, in the analysis of the algorithm, I think in class we assume that the task has been ordered by the finishing time, so the algorithm will be pretty simple. But in our case, if you look at the task statement, it doesn't say anything about the order of the finishing time, the T, right? Okay, so you need to sort it yourself. Okay, so so be careful. Okay, in class it might be has more assumption than the one in the task statement. Okay. Okay, so how can you prove that this algorithm works? I'm not gonna go through it, but the idea is that you use the use of you try to say that greedy algorithm stays ahead. Okay. Um, it stay ahead in the sense that it's better than everything. Okay, in this case, in the interval scheduling, it stay behind. Okay, in a way. So you want to prove the fact that after choosing one task, greedy algorithms, like the ending time of the greedy algorithm is gonna be as early as possible. So it's stay ahead in the sense that it's earliest. Okay, like if you pick this, if anyone pick the first, pick at least one task, one request, the ending time, the finishing time cannot be earlier than the one that the greedy algorithm has picked. Okay, like this one. So the second one, and the third one, and the fourth one. Okay, so if you pick, no matter how you pick, the ending time of the first item, the first request that you pick cannot be earlier than the one that we have picked. Okay, and you keep proving that. Okay, for each step of the greedy algorithms, you ensure that no one is ahead of you. Okay, in the terms of the earliest ending time, finishing time. Okay, given that, you can be sure that if anyone can pick, say, 10 requests, you can also do that, because for each one that you pick the ending time earlier than the one that the other guy pick. Okay, so this is the key idea on how to prove it. I'm not going to go through the proof, but when you design the algorithms, you can think of it. You can guess, right? And then you try to reason inside your head. Okay, why this would work? Okay, all right. So let's try to write the code for this problem. Okay, so N, S, and T. So the whole idea of this problem is like you need to sort. Okay, so that's the whole thing. Okay, you need to sort, and you need to remove when you go through the task, you look at the task based on the finishing time, and then you just ignore everyone that is in conflict with the one you are looking at. Okay. Okay, so I'm not going to use C on today because it will ruin my battery. Okay, my power. So okay, so this is a code that read the input. Then I need to sort the request based on the finishing time, right? Okay, so then I'm gonna have the vector. Then it's a vector of pair in int. Okay, I'm gonna keep the index. So the first part of the pair will be the finishing time. The second part will be the index of the request. Okay, so I'm gonna call this as request, and then I'm gonna say request push back make pair ti, and then I. Okay, so okay, you can for newer version of C++, you can write this succinctly, but let me do the old way. Okay, and then so we start by read input, and then we call sort request dot begin request dot end. Okay, you also need to include algorithms, include vector. Okay, now so after the request has been sorted, we need to go through all of them, right? Let me count the number of requests that I have accepted. And for I'm gonna go through everyone. So request R that I'm gonna look at is this one. Request I second. Recall that the second argument, the second argument in make pair is the index. Okay, and the finishing time. Okay, so previously I need to recall that the previous task, the previous request that I have already accepted. I need to recall the finishing time of the previous request that I accepted. So let's call it previous t. I initialize to -1 so that it means like the previous one has been accepted at something less than anything that is possible. Okay, so now, I'm looking at request R. So if T of R, no, if R start before the previous T, so this is the last time that I accept. Let's look at the picture. Okay, so when I look at the task, I have this previous T. So suppose I accept this task. Okay, I have this previous T set to this point. Okay, when I look at another task, if it begins before previous T, then I know that I cannot accept them, right? So I just kick it out. I just ignore it. When I see the first one, which start like at T or after T, then I know that, okay, this is the first one with which is compatible with the one that I have already picked, and which has the minimum, I mean the earliest finishing time, so I would accept them. Okay, so that's the idea. So I need to do the comparison. So if S of R is less than previous T, then I just ignore. Okay, otherwise I would pick it. Okay, but instead of writing if like this, I would write something like at least this, and then I just accept them. Okay, so accept, and then do whatever it takes to keep track of the the task that you accept. Okay, so you need to update the count, change the previous T, and then that's it, and then you output. Okay, so that's the algorithms, but you need to do this yourself. Okay, all right, so that's the idea for this task. Okay, if you can do this one, you can go ahead and look at other tasks. So let me show you the other one that is related. So with this, you can look at scarecrow and fence. It's the same ideas. Look at fence. Okay, so basically you have a house, you have houses, and you want to put fences to cover them. The fence, each fence has the fixed length. Okay, so you basically need to cover them. If you want to do that greedily, you can note that you cannot, if you put a fence like this, it's okay, but you can move it further to the right. So that's the key. So you can look at this problem, and also with scarecrow. Okay. The optional problem radar is also related to this idea as well. So you should look at them. Okay. It looks not easy, but it's not that bad. It's not that hard. Okay. Okay. So the other idea that you learn in class is to use exchange argument. Okay. So the second task that you should look at is maximum late fee here. So you should pause the video and read it for a few minutes. Okay. Okay, I hope you read the task statement. Okay, so in this task, this is like what you learn in class, but there are some extra factors. Okay, so you have many jobs. Okay, and each job has a deadline, DI. job I has deadline EI, and there's some penalty. Okay, so if you get it done on the X, and if X is within 10 days, you have no penalty at all. Otherwise, you have to pay the amount, penalty rate. Okay, so if D is 1 and you finish it on the ninth day, then it will be fine. If you finish later, then you pay. Okay, so let's see. So each task has a deadline DI. Okay, and you look at it, you need to work on it. Okay, so if there's a duration that it takes you to finish the task, you need to finish all the tasks. Okay, all the job, and if it finish it after the deadline, it will be fine. If it's within 10 days. So let's say this is the hard deadline, say DI plus 10. Okay, so if it gets done in this range, you pay no penalty. But if it go through something like that, you would pay this amount times 1,000. All right, so this is the late fee. So in this problem, you do not want to minimize the total late fee. You want to minimize the maximum late fee. Okay, so this is in a sense that in business, you have already figure out like for whatever you do, you have to pay the minimum late fee, maximum late fee of at most like 5,000. So you already add this up into the cost of your operations. So to make sure that you not you not run into a deficit. Okay, so what you would like is not the total late fee, like the late fee of every job that you do, but you want max late fee. You want to minimize max late fee, the one that you pay the most. Okay, you want to minimize the maximum penalty. Okay, so if you call from the lecture, so in this task you basically you work, you order jobs by deadline. Okay, like the earliest one, you do the earliest one first. So in short, you do the earliest deadline first. So this is the greedy rule. Okay, you can prove that it works. Okay, so how would you do that? So basically you can just sort, right? Again, the code will look pretty much the same, but the way you sort the numbers will be different. Okay, so that's how you would do it. Okay, so I'm not gonna write you the code. Okay, so but you can use the previous code to prove that this idea is correct. You use exchange argument. Okay, I'm gonna really quickly go over this. So the idea is like maybe you have some optimal way to do to schedule the task, and this is the task that you do. Maybe you order them differently. The proof is like basically say that if you have a schedule with some space, you pack them up. That's easy. And then you say if the order, like say this is job 2 and 5, and in your task, job 5 come before job 2, you can basically switch them. Okay, and the maximum late fee will not change. So you basically look at adjacent inversion, and then sort of like move change the optimum solution to your solution repeatedly until you can say like for each time you do the exchange, the cost of the optimum solution doesn't change, and then after a while, after you change this in many steps, you end up with the same solution that you have. Okay, so that means that your solution is optimal as well. Okay, so that's the idea. Okay, and again, we're not going to look at the proof in this lab class, but you need to think about it. Okay, so that you won't make a mistake. Okay, all right, so let's go over the other tasks pretty real quick. The other two required tasks are pretty simple. Okay, let's look at the eggs first. Okay, so you have a bunch of eggs. Okay, basically a bunch of eggs, and you know the weight of the egg, okay, and you would like to boil them, okay, but it takes 12 minutes to boil the eggs, but you need to put them inside a bowl, okay, and a bowl, you cannot put more than p eggs in a bowl, and the bowl can carry at most q grams, okay. You know the weights of the eggs, so you would like to put as many eggs as possible, but the eggs has the weights of the eggs, right? But they're not order, okay. So you know, like this signature are the weights of the eggs, so you like to put as many eggs as possible to boil inside a bowl, okay, so that you want to maximize this, but you cannot put more than p eggs as well. So these are simple greedy problems. So how would you put as many eggs as possible? Uh, Eggs has weights. The bowl has the maximum weight that it can carry. So you basically, I'm not gonna tell you, but you should think about it. What should be the way to put the eggs? The other one is this. Okay, so this problem is about bus driver. So let me describe it in here. So you have in driver, okay, and then you have routes, morning routes and afternoon. Yeah. So the morning route has this is a distance. Some routes are long, some routes are short. Okay, and also the afternoon routes. Okay, and each driver has to you have to choose like the first there, say like a bunch of drivers, 1 2 3 4 5 6 drivers, and so on. You need to pick like say this driver, you need to drive this and that routes, okay. So that's the amount of routes that you have, that this guy has to do. So now if you pick them like that, okay. So this is how long that he needs to drive, okay. But if the amount, the distance that he has to drive in a day is larger than certain amount, you need to pay them the fee, basically the overtime fee, okay. So you would like to pay like um, okay, you would like to minimize the maximum overtime fee that you need to pay, okay. So need to basically in this task you need to pair up the morning routes and the afternoon routes like that to all of them, okay, so that you minimize the amount that you need to pay, okay. So you assign one morning route and evening route, not afternoon, sorry, evening route to the bus driver, so the total overtime is minimized, the total overtime amount, okay. So you can think, how would you pair up so that the overtime is minimized? Okay, you should think about the rules that basically somehow sort of like minimize the total overtime, okay. It's not that difficult, okay. How would you the idea is how would you balance the total driving distance for each for all the driver, okay. All right, so I think you should be able to complete most of the required tasks, and go ahead and work on it. If you have problems, ask TA or post it in the Discord. Okay, thank you so much.